So in the previous classes, we have learnt about linear equations. So recall, what is a linear equation? An equation in which the highest power of the variable is 1 is a linear equation. Now in this video, we're going to learn about quadratic equations. So what is a quadratic equation? See, a quadratic equation is an equation of the form ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a is not equal to 0. We can also say that if px is a quadratic polynomial, then px is equal to 0 is called a quadratic equation. So in simple terms, an equation in which the highest power of the variable is 2 is a quadratic equation. So if the highest power of the variable is 1, it's a linear equation. If the highest power of the variable is 2, it is a quadratic equation. Like over here, what is the variable? X. What is the highest power? 2. So it is a quadratic equation. Now see, because we have the term polynomial over here, what is special about a polynomial? In a polynomial, all powers of the variable have to be whole numbers. I repeat, in a polynomial, all the powers of the variable have to be whole numbers. So remember, whenever you're classifying any equation as a quadratic equation, what are the different things you have to check? The first thing you have to check is highest power of the variable should be 1. The second thing you have to check is all powers of the variable should be whole numbers. I repeat, whenever you're checking whether a given equation is a quadratic equation or not, keep two things in mind. Point number 1, the highest power of the variable should be 2. And next, all the powers of the variable should be whole numbers, right? So keeping that in mind, let's have a look at a few examples. So I've taken 6 equations over here. We have to determine which are quadratic and which are not. So I'll begin with the first equation, x squared plus 5x plus 6. So whenever we have to check whether an equation is quadratic or not, first check the highest power of the variable. What is the variable over here? X. What is the power of x over here? No power means 1. So highest power is 2. Fine. Next, are all the powers of the variable whole numbers? 2, 1, yes. So this is a quadratic equation. Similarly over here, what is the highest power of the variable? It is 2. What is the power of this x over here? No power means 1. Are all the powers whole numbers? Yes. So it is a quadratic equation. Similarly over here, what is the power of x over here? 1. So highest power of the variable is 2. All the powers are whole numbers. So this is a quadratic equation. Simple. Come over here, x plus 4. Now, what is the highest power of the variable over here? Here, what is the power of x? 1. So the highest power of the variable is 1. Is the highest power 2? No. So this is not a quadratic equation. In fact, this over here is a linear equation. Next, x cubed plus x squared plus 3x plus 5 is equal to 0. So what is the highest power of the variable? Here variable is x. The highest power is 3. Is the highest power 2? No. So again, this is not a quadratic equation. Why? Because the highest power is not 2. Next, x squared plus 2 root x plus 5 is equal to 0. So what is the highest power of the variable? 2. Now, what is the power of x over here? See, what is square root of x? Square root of x means x to the power half. Is half a whole number? No. So because the power of x over here is not a whole number, this is again not a quadratic equation. I repeat, square root of x means power of x is half. But for a quadratic equation, all powers of the variable have to be whole numbers. Is half a whole number? No. So this is not a quadratic equation, right? So these 3 are quadratic equations, whereas these 3 are not. So this is the basic concept of a quadratic equation. I repeat once again, what is a quadratic equation? An equation in which the highest power of the variable is 2 and all powers of the variable should be whole numbers. See, highest power of the variable is 2. I repeat, highest power of the variable should be 2 and all powers of the variable should be whole numbers. Here, highest power of the variable was 1, not a quadratic. Here, highest power was 3, not a quadratic. Here, highest power was 2, but then this x, right? The power of x over here is half. So because the power of x over here is not a whole number, hence not a quadratic equation, right? So this is the basic concept of a quadratic equation. Now if you notice over here, I have written a cannot be equal to 0. So see, what are a, b and c? A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So I am saying a cannot be equal to 0. That means the coefficient of x squared cannot be 0. Why? See, we have a quadratic equation ax squared plus bx plus c is equal to 0. Now what will happen if a becomes 0? So if a is equal to 0, replace a by 0. So 0 into x squared plus bx plus c is equal to 0. 0 into anything is 0. So we simply have 0 plus bx plus c is equal to 0. Therefore bx plus c is equal to 0. So see, if a is equal to 0, what will this equation become? Bx plus c is equal to 0. What is the highest power of x over here? Power of x over here is 1. I repeat, power of x over here is 1. For a quadratic equation, what should be the highest power of x? Very good, 2. So is the power of x 2 over here? No. So it will become a linear equation. That means if a, that is coefficient of x square, becomes 0, we'll get a linear equation, right? Hence, a cannot be equal to 0. I repeat, why cannot a not be equal to 0? See, a is the coefficient of x square. If the coefficient of x square becomes 0, this term is gone, so we're left with bx plus c is equal to 0. So what is the power of x over here? 1. So highest power of the variable now is 1, but for a quadratic we need 2. So if a becomes 0, we get a linear equation. Hence, a cannot be equal to 0. As you can see over here, 2x square minus 6x plus 9 is equal to 0. See, highest power of x is 2. See, b can be 0, c can be 0. What I mean is, if I give you an equation like this, x square plus 4 is equal to 0. See, as you can see, the coefficient of x square is not 0, but there is no x term. This is a quadratic equation, right? This is a quadratic equation. But if I remove the x square term, it will no longer be a quadratic equation, right? So I hope the concept is clear. So in general, it's very, very simple. An equation in which highest power of the variable is 2 and all powers of the variable are whole numbers is a quadratic equation. Just remember, the coefficient of x square can never be 0. Why? If coefficient of x square becomes 0, we get a linear equation, right? So this is the basic concept of a quadratic equation.